So in this case, we are going to continue with our transformers, working with the no load condition of a transformer. Remember on the basic introduction that we had, we said the no load is a condition where we are dealing with what? An open circuit, where the secondary side of the transformer is on open circuit. So during that part, or during the condition of an open circuit, the secondary winding is left open circuited and the transformer draws a small amount of power from the supply. Remember, you'll be having the no load current from what? The primary side. On the secondary side, you are going to be having what? An open circuit that's open. We do not have a load on the secondary side. So the power that we are referring, the small power, is from what? The no load current. Remember, that's the current that is being what? Being produced, a small amount of current. And for the secondary side, we do not have anything because it is what? It is open. All right. So the output of the transformer is what? Is zero. But on the primary side, we have what? A no load current, very small amount of current which can be used. All right. So I'm not gonna dwell much into that. We refer this on our introduction. So what I want you to understand, I'm just gonna extend from what we had. I'm going to give you guys the circuit diagram, on no load. All right. And this is the one that you're going to have in your syllabus for N4, N5. You're going to work with when there is a load, but this one, it is no load. All right. So this is what you're going to have on the primary side. Going to have our resistor reactance, but we're not going to dwell much into that for now. All right. For now, we're not going to dwell much into this. It is going to be our N5. So we just need the basics. Do not even worry, guys. It's just the basics. What you're doing under transformers for your level are just what? Are just the basics. So this is what we're gonna have. So this is the primary. We have extended our primary side, also including the reactances. All right. Then this is the secondary side, which will be what? Which will be open. So the secondary side is gonna be open. All right, so the primary side, we've got V1 and we have got the no load current. This is the resistor R1. This is the reactance X1. And here, the no load current is going to be extended, giving us the magnetizing component and the core component, which is our core loss component. So this will be our core loss component, our magnetizing component. All right. So these are the components giving us what? The no load current. And this is just representing our E1. And on the secondary side, this is going to be our E2. And this is our resistor. So that's R2. And this is the reactance, which is X2. And the output is what? The output is zero because of what? Being on open circuit, our output is going to be zero. So this is the idea. We separated the primary and the secondary what? Windings. And from this, we are going to see that this no load current is actually a phasor sum of what? These two components, the magnetizing and the core loss. So this gives us what we refer to as the vector or the phasor diagram, because we are saying it is what? The phasor sum. So that's our phasor diagram. So the no load current is obtained from what? from the magnetizing and what? And the core loss. So this will be our no load current, which is the phasor sum of two, the magnetizing, where we have got what? The flux, and this will be our magnetizing current component, this one, and this will be our IC. So if we are to complete this triangle here, guys, we're going to see that this is our IC here. All right, this is our IM, and we are going to have the angle that is represented no load, which is here. This is the same as the angle that is also found here. So take note where we have got this angle, guys. Take note where we have got this angle. All right, and the vertical is going to carry the voltages, normal voltage, V1, and the EMF, which is E2. So this is the idea, guys, and we can actually play with our mathematics because we are saying our no load is actually the phasor sum. So that's from our Pythagoras. That's the square root of what I am and I see. The squares I am plus what I see squared from our Pythagoras theorem. That is the phasor sum. And according to the angle theta, you're going to notice that according to the angle theta, this IM is our opposite. IC is adjacent, 90 degrees and theta are on this side. That's adjacent. And this is our hypotenuse. So you've got those ratios, guys, the SOHCAHTOA concept that we can actually apply. The sign of what? The sign of the angle. The sign of the angle is what? Opposite over hypotenuse. Opposite over hypotenuse. That's IM over I naught. Then the cos of the given angle is what? Adjacent over hypotenuse. Adjacent. IC over what? Over I naught. We can also consider the tan. But in our case, we're just going to focus with sine and what? Sine and cos. So these are the things that we can actually obtain from this understanding, guys. All right. So from this vector diagram, formulas are being what? Produced, or calculations. So the formulas or calculations that you're going to need, one, it is, all right, we can consider N1, guys, here. From this, we can find IC, we can find IM, all right? Because mostly you'll be given IO, that's no load current. Maybe you are given that. So we can write IC in terms of IO, you can make it the subject. So simply multiply by IO here, IO here. So this is going to cancel. So that's IC, which is the IC is going to be what? IO times cos theta. You see where it is coming from, all right? Which is our core, our core loss component. Then the magnetizing can also be determined from this. Just multiply here, cross multiply. So that's IO sine of what? Sine of theta. All right. I talked about this IO as what? From our Pythagoras. We can use that Pythagoras. Hypotenuse squared is equal to the square of the what? Shorter sides. So we're going to introduce the square root. So that's the square root of IM squared plus IC squared. All right, what else can we consider? Remember, the power can be calculated. Power can be calculated if we are to consider V1 and IC. It gives us what? Power. All right, voltage times what? Current. So power can be calculated as voltage times what? Voltage times current. So along this, it will be voltage times what? Times current. But remember, IC is equal to what? IC is equal to this. So meaning to say it's going to be voltage times current times this in place of IC. So that's IO cos of what? Cos phi. All right. I was saying theta or phi, guys. This is supposed to be phi, all right? Not theta. All right. Let us just use the phi. Okay, it's phi there. So that's what you can have. This is the basic of what you're going to need. All right. So I have already talked about this, guys. I all representing what? No load current. All right, definitely from the is drawn from the supply, this one. Then IM, we talked about this magnetizing component. Magnetizing component. Okay. And IC, which is the core loss component. Core loss component. All right, what else do we have? We have the angle. Angle, there is the no load phase angle. All right, so that's the no load phase angle. Okay. And we also on this other diagram, sorry for that. On this one, we also had these reactances X1, X2, the voltages, this and that. So let us also add those ones. So those are simply reactances X1 and X2. The reactance on the primary, the other one on the what? On the secondary. So these are simply reactances. All right. Then we have got R1 and R2. Those are resistances. All right. These are resistances, one on the primary, another one on the secondary. Then E1 and E2 induced EMFs. All right, induced what? EMFs. And we have V1 and what? V2, normal voltages. Those will be your normal what? Normal voltages. So that's it. In a basic calculation, yeah, this information, guys, is important. You just need to know this and to know that no load secondary voltage, which is the no load secondary induced EMF, is the same as what? E2. That's E2 is same as what? Is same as V2. So it is the same as what? V2. All right, so guys, no load, open circuit. These are the things that you need to understand. These are the things that you need to understand. So basically, I want you to go through these basics, all right? Then we are going to look into questions, especially on these calculations here, knowing the vector diagram or the phasor diagram of a no load and these formulas, all right? Using our trigonometry from our N4 mathematics, all right? This is just trigonometry that we are playing around here. So we will see in the next class adding questions on what we have on these notes, all right? But for now, that is it. Till we meet again.